to start. So you got this reaction going on, right? So which statement best explains why the reaction should be classified as a Brostad-Lowry acid-base reaction, right? I mean, basically an acid-base reaction. Why is it an acid-base reaction?
Number one.
The ammonium ions, the ammonium ions they got H+1, now they don't have H+1. So that means number one is fine. Is number two, so basically it's number one, only number one, right? Because that's what the theory is, that something is a proton, no, that's an acid, right? Now remember, in the Brostad-Lowry acid-base reaction, it's not necessary that a salt gets produced. The definition is pretty broad. Someone losing H+1, someone gaining H+1, that's it. It's got nothing to do with salts. And ammonia is not always basic because ammonia is basic, but ammonia can also lose H+1 ions. It's got H+1 ions, so it can possibly lose H+1 ions. So we're not really sure whether it's always basic. So that we can't be 100% sure about that. Okay. Chalo, ignore this one. The table gives the concentration and pH of the aqueous solutions of two compounds, X and Y. Either compound could be an acid or base. So there's 2 mole per dm cube X, 2 mole per dm cube Y. This has a pH of 6, this has a pH of 9. Student P concluded that X is a strong acid. And is he right? Is student P right?
No.
It is an acid though, right? But it's not a strong acid. And student Q concluded that the extent of dissociation is lower in X than in Y. Look at the pH. Who's going to dissociate more? Who's stronger?
X.
Why do you think X is stronger?
Because it has a lower pH.
Well, X is an acid, right? Y is actually a base, right? So when you're 7, right? I mean, 7 is the midpoint. 7 is when it's neither, right? So he's not talking about whether it's acid or base. He's just talking about which one is stronger, which one is more, it's going to dissociate, which one is going to dissociate more. So relatively speaking, the base over here is relatively a stronger base, right? Is that clear?
Oh, because it's 2 more than 7.
Yeah. I mean,
Okay.
6 is a lot closer to 7. 9 is like a little further off, TK. So the extent of dissociation is lower in X. That's fine. That's fine, TK. So Q is right? So only Q is right.